Hi, in this video, we'll explore the constant step out strategy from Pro 3D HSM. This strategy generates a toolpath with equidistant passes uh, on the target. It maintains constant step over throughout the machining surfaces. The goal of this strategy is to keep the same distance between the each pass, which results in a uniform cusp height on the given machining surfaces. This helps achieve a constant surface finish across the both steep areas as well as the shallow areas. Constant step over is ideal for semi-finishing and finishing operations, especially in the mold and die industry where surface quality and accuracy is critical. It works effectively on complex 3D surfaces like we see on this model, including both steep walls and flat floors as well. Let's now create the toolpath using this strategy. We will apply to the to this part uh, with varying geometry and observe how SolidCam generates a smooth and uniform pattern, automatically adjusting the shape of the surface. Uh, let's create a toolpath on specified machining surfaces, local surfaces. First, I will choose the tool. I will choose ball mill, 8 ball mill, and I will go to constraint boundaries, and I want to create the boundary just by picking the surfaces. So I will select the selected surfaces method to create the boundary, and I already have this surfaces selected, and I will reverse this. We have to make sure the chain direction is set to counterclockwise for the boundaries, especially when the trimming criteria is set to tool contact point. So now we want to machine this area, okay, and we have adjacent surfaces. So in order to keep the tool away from the adjacent surfaces, we have to enable the tool contact point. It means it will try and exactly machine the surface that we defined. So the tool will be inside the boundary that is generated here. So I will go to, we don't need to, define the drive curves because I want my toolpath pattern to be same as the boundary. So I'll go to passes and I will define the step down and just hit the calculate button. So this is the toolpath is created, and if you look at the toolpath near the adjacent surfaces, you see it exactly created and it respects this wall and it doesn't go beyond that wall. And if you look at the step over between the each pass, it's a uniform step over. And and if you look at also the shape of the pattern, so here we have a different pattern, here we have a different pattern. So it actually adapts the toolpath pattern based on the surface that we select for the machining. So key benefits is that we can achieve uniform cusp height. Hence we have excellent surface finish, and the constant step over, you can use it for shallow and steep areas as well. It's not like constant Z can be used only for a steep, and linear can only be used for shallow, but constant step over is used for both shallow and steep areas. And it has a smooth machine motion because continuous flow reduces the machine stress and improves tool life. It's a perfect for finishing detailed cavities and cores like we see it here. So if your part demands a balanced surface finish across, varying slopes, the constant step out strategy in Pro 3D HSM is an excellent choice for achieving, excellent surface quality, as well as optimized toolpath pattern based on the surface, based on the shape of the surface. Thanks for watching. See you in the next video.